All right, today we're going to be looking at section 2.1, set notation. So I'm going to start out thumbing through the learn section. These are the objectives, and I'll point out what's important, and we will practice it when we get to the problem section in Hawks. So it's very good reading if you like to read through everything. We're doing set notation. It was developed by a mathematician named Greg Cantor. Sometimes they're referred to as Cantor sets. So you have a definition of what a set is. You have what we call roster notation, which is kind of like a class roster. You list all the people in a class. The same, we do that by listing all the elements of a set. Sets are normally denoted with a capital letter. Okay, so A, B, C. Any capital letter usually represents a set. And then you got some little images and some examples here provided, which I'll go through all the examples with you in the problem section. Here we have two sets are equal if they contain exactly the same elements. Okay. And then we write that notation with A equals B if A and B are two sets. Cardinality is asking for how many elements are in a set, and it looks like some absolute value bars. That's the notation for cardinality. This means how many elements are in there. So you see this example, A, B, C, D, E is in the set. So what looks like absolute value bars of A equals 5 just says that there's 5 elements in the set A. And then so here are some more definitions in mathematical terms as far as cardinality is concerned. And then we also have equivalent sets. So two sets are said to be equivalent if they have the same cardinal number. So maybe not exactly the same, but they have the same number of elements. And here's the notation for equivalent. Here's a hint that shows sometimes cardinality may be denoted with other terms. The most commonly used one that I'm familiar with is this N, and then the set in parentheses, so number of elements in A. These other ones are just other notations that you may see. So here's some more examples. Another example. All right, so set builder notation. Here is what that looks like. So these curly brackets are the biggest indicator of a set. You read this as A equals, okay, and when you see the curly bracket, this is the set of all, and then X, so whatever letter they use here. So they'll use some variable, the set of all A that have a certain property, the set of all X. So this is the set of all X, and then this vertical bar is read such that, and then the following property is true. So we're looking at all the variables where X is a fraction and 3 is less than X and X is less than 4. So basically everything that is between 3 and 4. So here's another definition, and then it also tells you how to read it down here as well. If you're not familiar with the numbers in their groups, here are some what they call thin backs or hollow letters that represent different numbers. So R real numbers, N natural numbers, Z integers, W whole numbers, and then all of these are infinite sets. So there's some more examples. More examples. Empty set, important to know that. What looks like a circle with a line going through it means that A has nothing in it, or you can just write A equals and then you can write the curly brackets with nothing in it. However, it says the empty set should not be confused with both of them put together. This would be incorrect. Or if you put curly brackets with 0, because 0 would be a number. 0 is something that would mean there's one element in the set. So either you just do the empty bracket or you do the circle with a line through it. example, and then we got the universal set. So U is what we call the universal set. It is the set consisting of everything within a specific problem. So it may not be everything in the world, but the universal set will be given to you. So the universal set could be 1, 2, 3, 4, 5. So that means as far as this problem is concerned, we're only considering numbers 1, 2, 3, 4, 5. So universal set just means everything related to this problem. Complement. I usually describe this as everything except for the elements in A. So here's the mathematical definition. Complement of a set A are all the elements that are in the universal set but are not in A. These are some notations to denote complement. It's A, which I call A prime, A with a little c, and A with a vertical bar. This A with the apostrophe or A prime is the most common one that I'm used to using. And then you have some examples here. And then I think from here we're going to go ahead and jump into the problems in Hawks.